Modern text-to-image models like DALL-E or Stable Diffusion are incredibly powerful, capable of generating photorealistic images from complex textual descriptions. They are often trained on multilingual datasets. However, a subtle but crucial problem arises when dealing with cultural nuances. When prompted in different languages describing the same culturally specific scene, these models often fail to capture the intended cultural context, defaulting to generic or English-centric representations. Think of prompting for a tea ceremony in English versus Japanese. Are you getting geishas, tatami mats, and specific tea sets, or just a generic picture of tea? The key insight here is that the models do possess cultural knowledge, gleaned from their training data. The problem isn't a lack of information, but rather that the culture-specific representations within the model are not being adequately activated or utilized when prompted in non-English languages. The authors hypothesize that specific neurons, or groups of neurons, within the model are responsible for encoding cultural information. The problem is how to identify these neurons and boost their influence at inference time. The paper introduces a multi-stage process. First, probing is used to identify culture-sensitive neurons. This involves feeding the model carefully crafted prompts representing different cultural scenarios and analyzing the activation patterns of individual neurons. Statistical methods are applied to determine which neurons exhibit the strongest correlation with specific cultural contexts. Next, they propose two complementary strategies. Inference-time cultural activation directly amplifies the activations of the identified culture-sensitive neurons during image generation, without altering the underlying model weights. The second strategy, layer-targeted cultural enhancement, involves selectively fine-tuning only the layers containing the most culture-sensitive neurons. This allows for a more efficient and focused adaptation of the model, minimizing the risk of overfitting or disrupting its overall performance. To quantitatively evaluate these strategies, the authors created a new benchmark dataset called CultureBench. This dataset consists of prompts and reference images designed to assess the cultural consistency of text-to-image models. The results demonstrate that both inference-time cultural activation and layer-targeted cultural enhancement significantly improve cultural consistency, as measured by automatic metrics in human evaluation. Crucially, these improvements are achieved without sacrificing image fidelity or diversity. This is important because we don't want to just create stereotypical images, we want to preserve the model's ability to generate creative and varied outputs within the intended cultural context. This research highlights a critical limitation of current multilingual text-to-image models and provides practical solutions for addressing it. By identifying and activating culture-sensitive representations, we can create AI systems that are more aware of and responsive to cultural diversity. This has significant implications for a wide range of applications, from education and entertainment to cross-cultural communication. Future research directions include exploring more sophisticated probing techniques, developing more robust metrics for evaluating cultural consistency, and extending these approaches to other modalities, such as text-to-video generation.